All right, today we are replacing the words input and output for the word function table, and our input is going to be represented with an X. Oh no, I don't like that it covered that up. Let me use the highlighter. It is represented by an X, whereas our output is our Y. So we are going to replace the X in the function rule with the values for X from the first column of the function table, then use the rule to solve for Y. Remember, in a function table, there is exactly one entry in the second column, Y, for every entry in the first column. So for example, for the function rule, Y equals 5 plus X. If X is equal to 1, then Y is equal to 5 plus, and then we replaced 1 with X. All right, we'll get some more help on these next examples. All right, here we have Y is equal to 7X. And if we remember, 7X means 7 times X. So I'm going to rewrite my equation. Y is equal to 7 times X. 7 times, and X is 0 here. What is 7 times 0? 0, and that's my answer for this first column, or no, row of my function table. Next one we're going to do is Y equals 7 times 1. 7 times 1, I replace the 1 for X. 7 times 1 is 7. Same thing, Y equals 7 times 2. 7 times 2, replace the 2 with X. 7 times 2 is 14. Y equals 7 times 3, 21. All right, next one we got here is Y equals 36 divided by X. So I'm going to write my answers in green. Y equals 36 divided by, replacing it by 1. 36 divided by 1, that equals 36. Because 36 in one group is 36. I replaced X in this for 1. Y equals 36 divided by 2. 36 divided into 2. If I can't remember my division, I can always do this. 36 into 1, 2 groups. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So I should have 18. I'm not going to count them all, but there's 18 in each. So 36 divided into 2 groups is 18. Y equals 36 divided by 3. 36 divided into 3 groups. All right, 36. I could do the same thing where I have 36, but here I have 3 groups. I know my multiplication already, so I know that 12 is 36 divided into 3. So 12 and then 36. Y equals 36 divided by 4. I'm replacing 4 for X. 36 divided by 4 is 9. All right, next one. All right, here we have Y equals X divided by 10 plus 3. So we have our input, which is our X, and our output, that is our Y. So I already solved it for the first one. So now we're going to do the second one. Y equals, in parentheses, 30 divided by 10 plus 3. 30 divided by 10, I'm doing that first because that's in parentheses. 30 divided by 10 is 3 plus 3 equals 6. I put that here because it's my output for 30 as my input. Next one, Y equals parentheses 40 divided by 10 plus 3. 40 divided by 10 is 4. 4 plus 3 is 7. Put that for 40 because 40 was my input. Y equals 50 divided by 10 plus 3. 50 divided by 10 is 5 plus 3. Y is equal to 8. All right, next one. Y equals parentheses 60 divided by 10 plus 3. Do 60 divided by 10 because it's in the parentheses. In order of operations says that's first. 60 divided by 10 is 6 plus 3. 6 plus 3 is 9. All right. So Joanna has spent $120 for spending money on her trip. She estimates she will spend $20 per day. Okay, so she has $120 for spending on her trip. She estimates she'll spend $20 per day. So that means she's taking away $20, right? Because when you spend money, do you add it or do you take it away? Okay, so what we would want to do is how much money will she have left after 3 days? Okay, so 120 equals, she spends $20 per day. 120 is my, oh, I don't like this problem either. Oh, these are hard, 5th graders. They are hard. Okay, so day 1, she started off with $120. She spent 20, and then she got 100. Okay, 100. We got that. However, if we take 120, which is our total, take away 20, won't we get 100 the second day? Yes. So we have to figure out how to incorporate the number of days into our equation. So for day 1, we said 120 minus 20. Well, couldn't I multiply that by 1 and still get 100? The answer is yes, because that means 1 day. So what if we did 120 minus 20 times our number of days? 120 minus 20 times 2 is 80, which would be $20 less than day 1. So that works so far. Let's continue. 120 minus 20 times 3, because there's 3 days. 120 minus 60 is equal to 60. Let's continue on and see if it works all the way through. 120 minus 20 times 4 is 120 minus 80, which equals $40. 120 minus 20 times 5 equals 20. So let's see, are we constantly going down $20 between each day? The answer is yes, but the question is, how much does Joanna have after 3 days? After 3 days, she has $60. That one is confusing. Okay, Sal and Yoko have a leaf raking business. For each house, they charge $3.50 per hour plus an additional $10 to haul away the leaves. Okay, so the number of hours is our input and our output is how much they spend. So E is how much money they will earn. Okay, so $3.50 per hour. When we see the per, we know there's going to be multiplication involved because it's multiple hours. So $3.50 times H, our hours, plus the $10. They're always going to charge the $10, so it's always going to be plus 10 after the amount of hours they spend. Okay? So let's just see if it works for our first part. So it says 17 is our E, which is why I put it there, equals $3.50 times 2 plus 10. Okay, $3.50 times 2 is equal to 7. 7 plus 10 equals 17. That is correct. All right, so now we have to figure out how many leaves to rake. If they rake for 5 hours, how much will they make? So we don't necessarily have to fill in all this extra stuff because all we want to find out is the 5 hours. So let's figure that out. I'm going to erase this. This is going to be a longer video than I thought. So our equation was E is equal to $3.50 times how many hours plus the extra $10 they have to spend. So I'm going to replace my H, hours, with 5. E is equal to $3.50 times 5 plus 10. Okay, so I know $3.50 times 5, $3.50 times 5, 5, 0, 25, 5 plus that, 17. And then I have to move over twice for my decimal. That's reviewing decimals. 1750 plus 10 equals 2750. So 2750 is how much money they made after 5 hours. All right. One last one. Oh, wait, no, this is for the next day. Never mind, we're done.